so welcome to my talk, which is an introduction to SQL. So this is kind of really going from first principles. If you kind of have any questions along the way, feel free to kind of jump in, because obviously like I've written this thinking about kind of how I think about it, but if you kind of see it differently, then it's kind of worth having a little discussion. Obviously this is a TechNomads meeting, so thank you to Kerry for organising. So I can't click, can you click?
Yeah, you just have to tell me when you want me
thanks.
to change it.
Okay, so who am I? If you just click again. So I'm a decision scientist, and I work at N Brown, which is a online retail group. We largely sell fashion, but there's also kind of homeware. So you've probably not heard of N Brown, but there's brands that often people know. So we have Giacomo, Simply Be, JD Williams, Home Essentials, Ambrose Wilson, to name kind of few. They're kind of our core brands. So I work within a data science team, and basically we're a central team that kind of supports stakeholders across the whole business. So it can be kind of, logistics, finance, product. It can kind of be anywhere, which is kind of really cool to be in that position to kind of see how the business is really functioning. Decision scientist, it's not a job title you hear very often. It's kind of like a flavour of data scientist, really. So my job is kind of focusing on helping stakeholders within the business kind of make the right decisions, rather than actually building like big automated ML kind of models, which we have a team that does this. It's kind of just a different specialism. So I've been working in data science for 2 years. My first role was in civil engineering consultancy, and that was where I really kind of started with SQL. Before this, I've been doing kind of more academic pursuits. So I was a geologist originally by training, and then I did a master's in paleontology. And kind of this is where I really got into data and kind of realised that I didn't actually want to be in academia, and I wanted to work within data science, kind of within a business, really. So before I actually got my first role, I'd never really done SQL, so I've kind of mentioned this later on anyway. All the sort of just random stuff, kind of, I'm a big fan of outdoor sports, kind of cycling, hiking, this kind of thing. But yeah, importantly for today's talk, I'm a really big fan of SQL, which I've put here is the underappreciated powerhouse of data science. Everyone's like, oh, I do Python, it's great, or oh, I really love R. No one ever mentions SQL, but you'll probably find that you do more SQL than you do Python within a data science role. Kerry's nodding, she knows what I'm talking about. So I'm kind of here sort of repping the name of SQL. It's a much kind of older language, I think, and it's got a lot of history, but it's very powerful for kind of working with data. I've put my kind of Twitter handle there if anyone wants to kind of follow or tweet about this. Not a big Twitter user, but I am present. Cool, if you want to move on. So, what is SQL? Sorry, just click it again.
Oh yeah, sure.
So, SQL, or sometimes we call it SQL, it's kind of the same thing. You often get like kind of two camps about how you pronounce it. I think originally it is SQL. It stands for Structured Query Language, and basically it's just a kind of programming language for accessing data within relational databases. There are lots of kind of different kind of flavours of SQL out there, and kind of the version you work with depends on kind of what your database system is. So that's Microsoft, MySQL, Postgres. They're all SQL kind of at core, but there'll be like small nuances in the syntax that are different, or the availability of functions. But if you know the principles, it's very easy to kind of switch between them. So if you click to the next one. So yeah, I kind of already mentioned this, like SQL is all about retrieving and kind of transforming data within relational databases. So what actually is a relational database? Basically, like, they're made of lots of tables, and that kind of table is in the next slide. You can just shift me along. Probably. Oh, actually, yeah. So here I've linked a sort of SQL try editor. It's kind of a little bit basic, but it's a really great place to start, and all of my examples are executable in this editor, so you can kind of try out all the commands I've shown kind of later on yourself, and this is where I've kind of based my examples off, if you just go along. So yeah, what is a table? A table is kind of like, a sheet in Excel. That's something everyone's familiar with. It's data kind of in a tabular form, but it's kind of more structured than Excel, obviously. But if you imagine a database is made of lots of tables, so it would be like, lots of different Excel sheets, but you can kind of link them together in different ways, and that's really powerful. You click again. So, what does a table look like? We've got an example here, and this is again from that W3 Schools kind of training exercise resource. So yeah, you've just got kind of, data in columns and rows. If you click, I think I've drawn a little diagram. So you have, your different columns, which are like vertically, and then records or rows kind of go horizontally, and then kind of the data inside this, each kind of single item of data is like a field. Just some kind of key jargon if you're kind of going to talk about these things. If you click again. So I'll come back to this later, but what's really important is to know about your primary key for a table. So this is just like that first column, which is really identifying your records or rows as unique. If you click again, I don't remember. Yeah. So what is a SQL query? So when you write SQL, what you write is called a query, and it looks in general like this. Kind of through this presentation, we're going to run through this kind of the syntax that you were using to kind of build up this query, to kind of help you understand the logic and kind of how this works. Kind of general practice, so you don't actually need to, it's not case sensitive, but the kind of convention is that you write your SQL commands in capitals, which I think just makes it easier to kind of read and know what is a table name versus, an actual SQL kind of command. And often in an editor, they'll kind of light up in different colours like this, as you can see, I've coloured them in blue. So a SQL query basically starts like, it kind of works down. The first bit, in your select part, you basically list what you actually want to retrieve in terms of data. If you click again. So the from, basically you're telling the database where your data is actually located in the system. You next then do joins, which is where you basically bring two pieces of data together using those keys that I kind of mentioned earlier. You then have a where clause, which is basically like a filter for rows, so you might not want absolutely everything in that table. You only want like specific scenarios, and you can describe these in all different ways. And then at the bottom we have a group by. These are very useful as you get into kind of more advanced SQL. These can be very kind of interesting and give you quite different results depending on how you use it, but in its most basic form you just kind of like squash your rows together so you don't really get duplicates within your data, because there can be scenarios where there are two records, but if you're only picking particular columns it'll look exactly the same and you don't really care. And then your order by at the bottom, if you click again, this is basically just you telling the system what's the order you actually want to view this data in when it kind of comes up in a results table. So if you move on to the next one, so run in a bit more detail about the selects. So as we kind of mentioned earlier, you list the columns that you actually want to see. Click again. So select star, it's a useful starting point in kind of all cases, especially if you're kind of exploring the data, you want to see kind of what the columns are, what does your data look like. Select star is just short for select all columns. You kind of want to be careful doing select star because if your table has like millions of rows, it might take ages to run. You can hold other people up with the execution. So often you can do like select top 10 star, select top 100 star, this kind of thing, to kind of make sure that you're not just like jamming up the system trying to load like 2 million rows at once. So if you go next. So the other thing you can do other than select star is actually like list the columns that you kind of want to see from a particular table. So this is like a query over the same table, but you can see I've listed those 3 specific columns. Again, in this scenario, I've kind of stacked the different columns vertically. You can write them in a big long line. I just think it makes it harder to read. And if you're wanting to then turn off a column, it's really easy to kind of remove that one rather than like having to scroll through a whole thing. So just like little kind of tips and tricks really. So yeah, this kind of putting down your columns, is useful if you have a really big table, or if you're joining lots of tables together, you don't want to see everything. If you have like 100 rows, it's just kind of impossible to think about. So you just pick out the columns you're interested in. If you can move on to the next one. So the from. So yeah, you're basically telling the database which table you actually want to pull your data from. So we're doing here, select everything from this customers table. If you click. So this C that I've put like the table name and then space C, this is called an alias, It's super useful. It often confuses people who first start. I know that it baffled me. You can call it anything you want. Generally, it's recommended you call it something sensible. Often people do like T1 or A and just work down as they add more tables, or C for customer. It's often useful kind of within your team to agree a convention on this, but it can literally be anything at all. And then if at the top, I don't think I actually put this in the annotations, but you can see I've written select C.star. So you're referring customers, that table, and then the dot is saying like table dot columns, and star means kind of everything basically. So if you click, so that alias is just a nickname for the table that you can use elsewhere in the query. If you imagine, a really complex query, it could be like 100 lines. If you can reference back to that alias, and you can follow where the columns come from at all times, because sometimes the same columns are in different tables and you could get different results based on this. So like it's kind of good practice to always alias your columns, but again you don't need it for it to work. If you click again, so these are kind of other ways that you can kind of actually do that select. So you could do C dot customer name and like actually specify the whole column name. C dot customer name, so use the alias and then reference the column, or you could actually not alias your table and then specify the table that's actually coming from, and then you can also just, if you only do it from one table, you can just put the column name itself, but generally that kind of first two is what I use the most and what I would kind of recommend as a kind of good practice. So if we move on to the next slide. So kind of mentioned this earlier, joins are kind of used to actually bring two different tables together, and this is all about knowing where your keys are. So your keys kind of are what links different data sets together in kind of different ways, and there can be like lots of like one-to-one relationship with the table where so one row relates to one row, but there can be one-to-many where one row in table 1 might be like 4 rows in table 2, and this is kind of really important to know. So the way your keys work, if you click once, so basically you can see that category ID is in the top table, and it's also within the second table, and this is how you'd actually join these two tables together. So if you click, so a little bit more detail about keys and how they kind of work. Within this first table, if you click again, sorry, they should have been animated. I've done this, botched it, just keep clicking. There we go. So you're on your first table, that column that's on the left hand side in most cases, I don't think it has to be on the left, but it's generally considered good practice, is your primary key for that table. It's a unique row identifier. They can be integers like this. Kind of different types of databases might have like long hash strings for this, but it's anything that signifies kind of a unique row. They can be made of like composite, where like combining two columns together makes it unique. This is a lot harder to work with, and generally this is kind of the best kind of situation, but it's worth knowing that there are kind of others out there. Then reference, what you call a primary key that is within another table is called a foreign key. So it kind of tells you, this row in the second table products, fits under category 1, and so does the second one. So you can see that one-to-many kind of relationship there, and this is how you actually join these two together. So if you click onto the next one. So kind of coming back to joins and kind of thinking about this, you can see we've got a select statement here, select star from categories, we've aliased it C, and then we're left joining a table called products, which we've nicknamed P, and then you can see we've done on C referring to categories, and then P referring to products and the column within those tables. So you're saying, basically telling the database, category ID on C is the same as category ID on P, and these are related through that key relationship. So if you do click, I've done some annotations around this, so I think I've already just talked through this. So so it's your foreign key and your primary key, you basically join them together, making sure that you're kind of referring to the right tables and things. So types of join, there's quite a few. There's 3 that I mainly use, so I'm just going to kind of run through these. If you just click, I've kind of written a bunch out here. So the ones we're going to talk about are left join, inner join, and full outer join. Right join is like the opposite of a left join. I once spent ages with someone coming up with a contrived scenario where one would need a right join. It's not something I've ever come across in the scripts in real life, but you never know, there's always a place for it. A self join is where you would actually join a table to itself, which sounds kind of wacky, but there are scenarios where this is really useful. You can use it as a method to detect duplicates in data and things like this. And then a cross join, which I've only ever done one, I think, in real life. It's quite complicated, where you kind of join lots of columns to lots of columns. I'm not going to run through that one. So if you just click to the next slide. So a left join, basically, if you have your tables A and B, you basically are adding data onto table A from table B. So if you click, so I've written an example of a query here. So we're joining customers and orders together on that customer ID. It's kind of very logical kind of name in this database, and you'd get a results table like this. What you can see is that because customers is our table A in this scenario and orders is our table B, you've kind of joined them together, but there is no record for this top row within table B that matches on those IDs, so you can see that it's filled in that order ID column with null. So this is kind of what you get. And if you click, I've kind of written this out at the bottom. So it adds data to A from B, where the record matches in A. If you click again, if there's no match, you get a null. And this can be really useful, you can use those nulls kind of to your advantage in particular scenarios. I would say left join is probably the join I use the most. If I do an inner join, I usually start with a left, because it doesn't delete anything, it just kind of adds labels. And then I then check the numbers don't change in a way that I wouldn't be, the numbers would change in a way that I expect if I move to an inner join. I don't always assume that, which might make more sense when we move on to the next slide. So an inner join, basically you're looking for records where you've got a match in those keys between both tables. So it's not adding labels on, it's like, is it in both? And if so, keep it. Anything else, it just removes the row from your results set. So we've got, again, another example query. So it's exactly the same, but this time we're just inner joining it. So if you click again, we'll have those be a data set, and you can see that we don't have, any null records under customer name, because they're all, it's deleted anywhere a null would appear. So kind of there's bullet points at the end for this. Yeah, so it returns records that match in both tables. If there's no match, it removes the row from the data set. So a full outer join, I probably use this one the least out of the three that I use the most, but it's always worth knowing about for kind of random scenarios. So here we've got, again, messed up the animations, we've got a table that shows you kind of what your results might look like from a full outer join query. If you click, I think the query will appear. So we're joining again customers and orders, and we want to see where the customer ID matches in both tables. But you can see that the first one has a match because we have a customer name and an order. The second one, you can see that we've got a null record, so that means that the customer's present but there are no orders for that customer. But then, there might be a problem in your database, these things can happen. You've got an order ID that is not associated to a customer. So if you click through, there'll be some bullet points. Quick note, full outer joins aren't supported by the editor that the examples are in, so I kind of imagined this up for you, but I feel like you can kind of get the idea. It returns all records from both of the tables when you put them together, and just kind of fills in nulls where the columns from A that aren't in, where the records aren't in B. So if you click, I think there's 2 points. Yeah, so if there's no match in either side, then you get nulls. It is useful, but kind of sporadically, from my experience. If you go to the next slide. So the next part down your SQL query is your where clause. So this is really used to kind of filter out your rows, kind of look for specific records that you're after. So if you click, So this is where we've kind of added in, we've got select star from categories, we're left joining products, again on that category ID key. And we've put where category ID equals 1, so we only want to see records where the category ID is 1 and where the product name, so this is like a text kind of filter, is like G, so that means anything that starts with G in this scenario. So I've kind of written some little labels if you just click a bit. So here you can see one thing that we've not really seen before is that you can put an and, where you can have like multiple conditions to kind of filter. You can also do this with joins as well, so left join on category ID and something else where that would be relevant. I don't have an example here, but that does kind of happen sometimes. And if you're doing an inner join, you can actually put an and within the inner join after the on, to actually filter out records before you get to the where as well, which can be quite useful.
Sorry
You okay?
Yeah, carry on.
Do you want to click again, please? We're running out of time.
Yeah, so we have 10 minutes left, and what we'll do is we'll leave and rejoin.
Yeah. So yeah, you can filter, on numbers. Just using this kind of equals, so checking for the equality on that. You can also do it on text fields. So you kind of put single quotes around strings when you want to kind of match on these. And then this percentage thing is a wildcard, and if you click, I've kind of written some things. So like is specifically for kind of wildcard searching, and you put the percentage symbol around kind of a part of a string that you want to look for. If you wanted something that begins with G, you do G percentage, but if you wanted something that has a G within it, you do percentage G percentage. I hope that kind of makes sense, but yeah, just playing with it and it'll kind of make sense to you. Do you want to swap out now, or we keep going? Do another slide?
Yeah, okay.
Cool.
I was just going to say one thing to note is that like is case sensitive as well.
Yes. Yeah, thank you.
No.
Yeah, that is useful to know. You can do some tests as well if you're not sure of this. I often kind of experiment to see if it is or not. So I've just kind of put some examples of what the where does. So without the where on this particular table, you'll see we just get like lots of rows with all these kind of different things. When we add in the where filter, we basically just find, if you click again, we just find that one row that was number 3 that begins with G, which is kind of what, when it's category 1 begins with G, it's kind of met our criteria. So the next thing is a group by. So this is like where we talk about kind of squashing these rows together where you get duplicates. And this is really useful as well when you do kind of slightly more advanced aggregation. It will start insisting you sort out your group by. It won't execute your query without it. You'll probably hit this error, but basically it'll mean that your columns haven't been included that need to be included. So yeah, if you click. So in this, we've done an inner join, and we want to group by the customer name field. So if you imagine, I think I actually wrote this out if you click. So if you want to list all the customers who've ordered, but some customers have more than one order, but you don't care that they've ordered more than once, you just want a list of all the customers who've ordered, this is kind of how you'd use it to kind of squash out those duplicates. So if you click, sorry, that's kind of shifted. But yeah, you kind of name specific columns that you want to group by, or you can actually reference them by the order that they appear in the select list. So if you have multiple, you can do group by 1, 2, 3, 4. You can do group by 3, 4, 5, 6. You can kind of do it in these different ways, and it'll be the order that they appear in your select section. Kerry actually taught me this about a year ago. I'd always been writing them out in full until you showed me that. So you learn stuff along the way all the time. So if you click. So I just kind of put some results to show you what the group by is doing. So without the group by, you can see that around the horn has got 2 records. So they've obviously got 2 orders within the table. But when you add the group by in, they kind of disappear because we kind of only want to see that record once. If we attached order number to it, they'd obviously appear, twice because there'd be an orders column next to it. That would have those different order numbers, but when we're removing those columns, we kind of don't care. So they're really useful when you filter down your columns. You can just squash your data so that it makes the most sense. Next slide. So order by, click. So yeah, it's just about kind of setting the order that you actually want to view the results of your table. You can order by like lots of columns in kind of different ways. So we're kind of building up the query here. We're selecting, 4 columns. We're doing a left join on the category ID. We've got our filter, this time for C. And we've grouped by all 4 columns that we've selected, so we don't want to see any duplicates in that. And we've chosen to order by 3 descending. So if you click. So what you can do is you can specify how it orders them. So desk for descending, it asks for ascending, and you can do like, you know, by 3 descending, by 2 ascending, and you can kind of specify it in different ways, which is really useful. If you click again. So if you actually want to like comment out a little bit of a query, you can just put like a double dash next to it, which is like really useful to know. You can write inline comments around your queries, explaining the logic. But in this scenario, I was kind of putting it in to show that these are the same things, 3 descending and c.product ID descending, basically. You can do it that kind of alias way or with the numbers. So you click. So basically, this is the results showing that, you know, your product ID descending, so you're starting with the biggest numbers and going down to the smallest numbers, and that's what it's done, because that's the 3rd column along. Yeah. So we've got 4 minutes. Do you want to swap, or are you happy?
Yeah, we can swap.
Yeah?
Yeah, let's do it.
Right. Now
So,
for a short break.
Yeah. Are you happy to log off, Patricia, and then we'll just log back on again?
Yeah.
Cool. See you in a second.
Do I leave?
Yeah. So we all need to just leave.
And I can rejoin with the same link.
Yeah. Wait till I end the meeting. There we go. So then we can just, rejoin the same link.
Want some more water, Fiona?
Oh, go on, I'll do it top up. Thank you.
Carrie?
I'm all right, thank you. Yeah.
Thank you.
Just a quick question about the group by. I think I just missed it. So what
Yeah.
does the 1, 2, 3, 4 mean? So I know the group by gets rid of the duplicates based on the columns in that one, but like, what was the 1, 2, 3?
So
and 4?
it's, you know, when you're select,
Yeah.
and you'd say select column A, column B, column
Yeah.
C, your 1 refers to the first column.
Oh, okay.
In
So,
your select list, your 2 is your second column.
mm-hmm.
It's kind of like a shortcut way, because I used to spend ages, like sometimes I'd have to select 30 columns.
Yeah, and then.
And I'd be writing group by group by group, you know what I mean? Like it'd be
So
group
you,
by
you
column
can
one,
put the
column
name of the column in as well.
two. Yeah, I'll run over that again, in case it wasn't clear for everyone.
Mm-hmm.
Unmute. Hello, is everybody back? Yes. Awesome. Are you recording again?
I did not stop recording.
Nice. Okay. A little bit of editing in the middle.
Yeah.
That's probably wise, to be honest. So if you can just jump back to the group by, we just had a question. One again, please.
Oh, yeah.
Oh yeah. There we go. The end of that one. So, it probably would have been easier if I'd have done this with an example with a few. But what basically your the numbers in the group by list basically refer to.
Sorry, I've lost my mouse. I can't find it. Right, I'm gonna have to. Okay. Sorry.
So the numbers in the group by list basically refer to the columns in the order that you reference them in the select. So if you select 2 columns, so say we had customer name, customer ID, that would be 1 and 2. You could just put like group by 1, 2, and it would know, and it just does it in the order. If you swap the name, the columns in order in the select, the group by just kind of automatically like recognises that when the next time you execute, like it's kind of not anything that's remembered. Does that make sense?
Yeah, that's perfect.
Yeah, cool. So if we jump back to, I think it's the aggregates one. And it's the same again with the order by and the numbering. It's exactly the same logic. So aggregates are something that's kind of really useful in SQL. So if you click, they're just kind of calculation functions that you apply over a column. So I've done a few examples. So you can do select count star as number of categories. So I've kind of given a column name to this generated column from category C, and what you can see is it says it's counted the number of categories that we have, and it said there's 8, and it's provided that column with that name, including that data. If you click again, so then this one, I've used the max function as your aggregate here, I've actually kind of nested them. So this in a bit length is working out it's calculating the length of all the category names in the table, and then I've said find the biggest category name that we have, and provide this, and then also tell us what the biggest name is and how long it is. So dairy products is the longest name length that we have, and that's 14 characters long. Kind of nesting kind of things like this can be like really useful. And then the other example is I've done average. So find the average product price within the database. So it's 28. I don't know what the currency is. £28 for example. And then if you click. Yeah, so here we're just using the as to actually assign a column name. If you don't assign it, it will function. It'll just, in where it says average product price, it would just say average price column. Like, it's just a bit ugly. And then if you're creating a table, then you're going to have to provide a name. It's always just generally good practice to keep track of these things. And then the other two kind of main aggregates are min, which works exactly the same as max, but it's the smallest number. Sum is very like count, but this time instead of counting the number of rows, it will like add together the value of those rows basically. So yeah, probably functions that you're very familiar with if you work in Excel at all. So if you go to the next one. So this one I've put kind of a bit further on just because it's a bit, a bit more complicated to push in it. But I kind of wanted to run through all that other stuff. This actually belongs to like the select section of a query. So this is called a case when. It's a kind of if statement really. So if you click, so case when are basically you use conditions to create a new field. So if you've joined two tables together, have some conditions, it'll generate an extra column on the end, and it'll have the results of this case when. So it's kind of like a conditional based kind of data generation. So we've said select everything from products, and if the price is greater than the average, which we calculated in the last slide, then put a 1, else a 0. End as, so give it a column name, above average index, or like indicator, kind of thing, like a flag. So if you click, you can kind of see that on that products table, I've created a flag that basically tells you if that price is above or below average. Yeah, and like kind of you can kind of do wacky things where you could put like a subquery inside that to make sure that you're rather than hard coding that average price, you can calculate the average price every time in case that kind of change over time, which can be really useful. But I thought I'd just kind of keep it simple for this example. So I think I've just put some labels to kind of go through how it works. So you have your condition, and then if your condition is met, then your first thing is if condition is met, then assign this value. Your else is like if the condition isn't met, what do you want to do? You can put numbers and strings. You can kind of do whatever you want with it really. You can add sums in here as well. You can add aggregates. It's really versatile. So if you click again. So yeah, the end just kind of, you need to always say end so it kind of knows that there aren't any more kind of conditions to come. Because you can have lots of conditions. When this, then this, when this other thing, then this, else, you can do really complicated things. It's very useful. You can click. So yeah, that was kind of everything that I was kind of wanted to run through. Again, kind of referencing and sort of thanking the W3 schools because I really relied on this when I first started, and I still reference it today when doing kind of things that I don't do very often. Other resources that are generally useful, which I think is generally underestimated and it sounds stupid, but like read the documentation for the database system that you have. I think people don't do this, but it tells you so much about like what functions are available. I wouldn't say read it back to back, but have a glance if you wonder if something exists, run a search on it. Just knowing what functions are available massively increases the kind of potential of your SQL code, and then just kind of use that and try it out. I think it's a great way to kind of learn, and I think that for me is what makes it a lot more interesting. I think if you just do this really basic things, people often say SQL's boring, but there's like so much to SQL, and it can get really complex and like advanced, which is that's where the excitement is, right? Useful place is always Stack Overflow. Just googling it when you have a problem. And then, I'd also say if you're in a team that uses SQL, share and read each other's code. You'll see someone else has solved a different problem the same way. Think about what's best, or like learning about different functions that they know about. That's just a really sort of powerful way to learn. If you click, I've put a little note. So basically it's saying SQL generally, beyond like the very basics, is really hard to learn before you actually get a job using the database, because this kind of opportunity to work with it is rare. From my experience at uni, people often kind of access online databases, but they just download a big CSV and then work with that data. There are these kind of little demo databases on the internet, but they tend not to be kind of as like nuanced or complex as kind of real business databases. But I would say kind of don't worry about that. Have an awareness about SQL, and if you're logical and you like coding, you're more than capable of learning it. The basics are very easy, but it can go like a long way. And I think just showing that you're want to learn it, I think that's enough to kind of get a role really. If you kind of show interest in that kind of data field. And I think the next one is any questions. Yes, so thank you very much. Does anybody have any questions at all?
I had one. If you go to the slide before resources,
Yeah.
it was the one with the case when I think it was.
Yeah.
Yes, you said you can do multiple whens and thens and stuff. So how
yeah.
would you go about doing that? So because you put that in the same line, so you just when P dot price is over than 28, then you just keep carry on saying when.
Basically.
Is that what? Is it just basically?
It's that simple.
Okay.
Yeah.
I was just wondering if there was like if that to be after else and stuff or something.
No, it's not. Like it's much simpler than that really. I think generally I put each condition on its own line.
Mm-hmm. Oh yeah.
It will run without it, but you'll hate yourself later, or your colleague will hate you when they come to peer review it. So you just do say if you want, you could do it like say when price is less than £1, then 1. If price is above average, then 2. You can kind of just do it like that. Mm-hmm. I don't know if I said the syntax right then, but I think you get the idea.
Yeah, you basically just carry on.
Just keep doing when condition, then different, then result, and then always end with an else.
With else, yeah. What else was the last thing?
So when I've done situations where I've wanted to capture every scenario within a when, I often put the else as like, I'll just write the word error in capitals with string quotes, and then when I get my results table, I'll search that results table for the error, and I know there's not an error if they don't turn up. Otherwise, that means you've actually missed like a condition that you wanted to capture, because otherwise your else 0 could be if you've got a product that's like at a negative price, which makes no sense, that will come up as a 0, as will something valid. So if you wanted to look for like, a specific thing or detecting a problem, that's quite a useful way to go about it.
Yeah, makes sense.
Yeah. So does the code fail without an else? Will it throw an error? Or will it just like leave a null field or?
Honestly, I can't remember.
Okay.
It certainly won't go without an end.
Right.
I suspect it wants an else. I kind of want to try it now.
Yeah.
Is it error
I don't know. No,
I've probably done that and not even thought about it.
No, that's fine.
We can do
I guess it's good practice to always have it, and I guess because you write SQL well, you always put the else in, so you already know.
I wouldn't even like question it. But early on, I probably did do that. 1 second, let me. I'll just test it here. Oh, actually, can you test it on your computer?
I have to stop sharing.
Well,
it's cool. Let me
if you
get.
just follow the link to my thing, and we'll just copy it in and do an experiment. Yeah, so just click that. A lot of it's trial and error, and a lot of it's like you'll run the code, it'll throw a wacky error, you're like, what's going on? You fix it, and then it hits another error. It's like all coding.
That's me with Python every
Yeah,
day.
exactly. It's the same. It's the same.
You only know you're making progress because it's a new error rather than the old one.
That's the thing, yeah. If you already know this, you're fine. So anything else? It's a from.
Oh yeah.
Products.
Oh yeah. Helping it. It didn't even error out, even though I didn't.
I think
It
it could have
did.
errored
Right.
on the top.
Again, this is like a sort of.
It works.
Oh,
There you go.
So yeah, it's
So it
null.
hasn't put anything.
Yeah. Okay.
There you go.
I can only just see the slides, by the way. I can't see.
Oh, sorry. Oh no.
Well,
Sorry,
spoiler
we'll
alert,
show you
so-
again. Yeah, I never do that though. I always put an else in.
Yeah,
I think
no,
I mean
it makes sense.
to do it. Especially the else error thing's pretty
Yeah, that's
cool.
really clever.
Yeah, that would have helped me. I
It's
think.
like when you search a LaTeX document for question marks where you haven't referenced something right.
Oh, sorry. Hang on.
It's okay.
Which
Nothing
screen?
Like a live demo at 300
There we
bucks
go.
for
So yeah, we just removed.
We ran exactly the same query as I had in the slides, but we deleted the else to see what happens, and basically it's just putting in null where the condition isn't met. Again, some database systems might do this, other ones might throw an error. That's the kind of thing that would differ between them. But yeah, learn something new every day. There you go.
And
What?
one, oh sorry, you go ahead.
No.
Okay, my turn, it's your turn.
Well, I think I don't know. Right. So yeah. You said database systems. What's like the most common ones that you use to use? So I don't know what a database system is, to be honest.
So like it's kind of about like the company that is your database architecture kind of built in their software. So the company I work for right now uses Teradata. Another like classic one is Microsoft SQL Server, which uses Transact SQL. If you have an Oracle database, it'll be Oracle SQL.
These are all ringing bells now. So it's like MySQL.
MySQL.
Yeah.
So that's kind of an open source one, right? I've never really used it. But it's essentially the same. So it's largely to do with who the company bought the software off, and they've all got like different tricks.
Yeah.
Ooh.
Yeah. What was your question? Sorry.
It's probably just like the way my brain thinks. Do the from and select statements have to be in the order that like there's a specific order, so it'd be select and then from?
Yeah, it's always so the order that I've shown you in that first slide it's always in that order.
Yeah.
So there's some extra commands that you can kind of put in the middle, but every command has its position within a query, and you can't move these out of order. It will sort of crash. And it'll say something like sometimes it'll say like expected from.
Right. Yeah.
It'll kind of say something like that. Other times it's a bit more ambiguous with the error, but like it's always select from, join where, group by, order by.
Okay.
And then there were some other kind of rare ones that you'd slot kind of after where and before group by, or if you have multiple joins, you do join where.
Yeah.
So it's always like that. So
Okay.
that kind of structure is really important.
It just seems strange that you'd select the columns before saying what table it's from. I don't know, in my head it meant select the table, then the columns, and then do the stuff.
Yeah, I see what you mean.
Again, if that's how it is, then that's how it is. But
I don't know why it's like that, but obviously when it kind of compiles and executes, it'll probably go to the table first.
yeah.
But it's probably done this way for like human readability by some way. That's something to do with how SQL itself was developed. I've never actually questioned
There's probably a reason, but
yeah,
just
that'll be
reality.
the internet will tell you that one.
Because I think before you had select C dot star, and then you went from category C, which is like you're going backwards.
Yeah,
Yeah,
I think
you
that
always
is
like
what
it.
confuses people. The
SQL
alias, you can reference it before you state
yeah,
it.
Yeah.
But I think
So
there's
it
other-
reads it as a whole and then does line by
Yeah,
line.
it executes it in a different. We have to write it like this, but that isn't how it executes.
Yeah.
I think is it Java where you can call a function before it's been defined, but in Python you've got to only call it
I
after.
think you can define
Or
anyway in
something
I
like
don't know
Python.
about Java. In Python you can,
You
but
can.
Java
Or I don't know.
Maybe
this-
the way around. Yeah.
something like this. It's the same. It's the same kind of logic. I think.
Yeah. Okay. Something to remember, because I was looking at it like, it doesn't make sense.
Yeah, no, I see what you
Okay.
mean. You get used to it after a while. You stop questioning these
How you
things.
just went select from, join, where. I was like, okay, fair enough.
Yeah.
It's like you have to remember what
It's,
it is.
yeah, you get once you start doing it,
Mm-hmm.
you won't forget.
Okay.
Patricia, do you have any questions?
No, none from me. Good talk.
Glad you liked
I was just going to mention that at my work we use DataGrip, and I think it's a really good IDE to use. I don't. Did you mention already?
No, I
Yeah,
don't. I didn't mention this one, but it's proven
Yeah.
the point. There's a lot out there.
Yeah, and then the data grips like syntax and error is really good as well. So then if you have made a mistake, it alerts you to it. So there are some really good IDEs out there, and like yeah, I'd recommend any JetBrains one, but data grip
Cool.
is really good as well. Because we've used Microsoft SQL Server Management Studio, and I really don't like that one.
Yeah, that's the one I
Compared to
learned, and
data.
it's a bit janky, isn't it?
Yeah.
Yeah, we use the Teradata SQL Assistant. It's exactly the same thing. I guess yeah, it depends. You know, if your team supports a different kind of IDE for this. Something we often do as well is we'll kind of optimize our our SQL queries within Teradata SQL Assistant. But then when you're happy with it, you just paste that into Python, and then use that to read your data set in, and then do like pandas or I don't know, whatever you're planning to do, kind of build a model over the top of that data set.
Okay.
Yeah.
So this is like a first step. Extract all the data we want and then let's play
Extract it, put it in the shape you want. It's much more efficient at handling big data sets than kind of reading it all into memory in Python.
Yeah.
If you're working locally, that's, on business data, that can cause problems.
Yeah.
Yeah.
That makes sense.
So go into the business data thing. So obviously you can't say specifics, but as a decision scientist, what would you use this like SQL for to really get? So you said that the data scientist would make kind of like the models for the data,
Yeah.
right? And then what would your doing be of using SQL?
Honestly, I use SQL in exactly the same way that a data scientist will as
Okay.
well.
Yeah.
So it's about understanding data sets, trying to find data, aggregating data, doing some like transform, you can kind of reshape it. So it's about collecting the data set you need to then have all the data you need from all these different tables in the right format, completely clean, ready to just go plot, scatter plot, magic, right? Rather than trying to like clean it all in pandas or something.
Mm-hmm.
So it'd be like kind of the first stage of collection, cleaning and transforming to then make it optimal for your modelling, your analysis, your visualizations. It's Power BI reports, for example, as well. Yeah. Does that make sense?
Yeah, it does. Yeah. So it's kind of like working on the same kind of way. Really.
Yeah, it's the same, I think.
So
Really.
there's not like I was thinking in terms of like they do their bit and you do about on top, or through like parallel kind of thing.
Like I'm on different projects than them.
Okay.
So we're both kind of starting at the same point.
Mm-hmm.
I think one thing that they do that we don't, that I think will move more in that direction in decision science is like they have to write SQL that's optimal for like productionization, automating within like AWS. So it's got to be really efficient because like running AWS like costs money. You don't want to be like wasting time and having really slow queries when you're working with so much data. I think that optimization is less important, but still important in my role, if that makes sense. And the more you get used to making your queries efficient, just the kind of the better you are, really. Anything else?
No, I think
No.
I think I'll just go and try it and then
Yeah,
all the
playing with
questions will come out.
it is the best thing you can do.
Yeah.
But yeah, like I was kind of saying, like really, you can definitely get to grips with Python while you're not in a role, because like there's so much out there, but without a database and without specific weird obscure business problems you wouldn't come up with, that's what makes your SQL good. It's being given like a mad question and you're like, oh my god, what am I going to do? And then you're like, oh, I found this function, it's amazing, I've written this wacky query but it solves it. That's where you really develop your skills, because otherwise you're just going to do like kind of simple select queries. You're not going to necessarily try and do anything really mad.
Yeah, it's not real life. Really,
Yeah, exactly.
Yeah.
And I think that's what's kind of hard. If you are feeling really techy, there's a Microsoft SQL Server Express that's like a free version, and there is a database that's got a lot in it.
Okay.
But you'd have to set up the whole database system, the users, so it's like DBA, and then you can actually play with quite a big database. It takes a while, but if you're really determined.
Yeah, it sounds like a bit of a TechNomads.
Yeah.
To set it up.
I did it
Take
while I was
it away,
furloughed, so but that's probably the best kind of simulation of a real database that I've seen. Again, I've not done loads with it, but the online ones tend to be very minimalist.
Yeah. This W3 Schools is that database that you just went through today, then, right?
Yeah,
that's that example one. Yeah.
So if can you go to so you can see on the right it's got this your database.
Okay, yeah.
They're all the tables that you have available, and they're all the tables that my examples are based on. You can even like drop the tables, which is how you'd actually delete them, and you click restore and it'll put them back.
Oh.
That will not happen in real life. You'll
Yeah,
be lots
well,
of
the
trouble.
drop will just
I was going to say, the undo for that isn't available.
But also, something that I kind of didn't mention is that you will make mistakes. So I think in my previous role, what was it? I'd written a query where I was supposed to update some records, but the test system that I was told to test it in it was good for software testing but not good for data testing. So I'd created like a simulation environment in the live database. The person that was supposed to peer review it didn't really peer review it, and they ran it at like 8 o'clock at night while tired and overwrote every record in the table instead of just the specific set. Because I was doing like a subquery that was like select star from, select, and then test it out. But when you run that in real life, it just like overwrote absolutely everything. And now I shouldn't have done it that way, but it failed at the second stage as well.
Yeah.
So, but what would be good, like in theory, it's also supposed to be reversible. So like if you have a good setup in your database, you can't when people are working with data, people will make mistakes, and you've got to accommodate for that and be able to kind of put stuff back. Or people do like database snapshots every week or something like this.
Okay.
But yeah, the mistakes will happen. I felt guilty about that for weeks.
It was also half on someone else's head as well.
Yeah.
So it
This
was
is the thing. This is the thing. That got through 2 stages, didn't it?
Exactly.
But you learn from it, and like everyone's got a story like that from
Mhm.
kind of speaking to people. But yeah, it took us like a week to fix it.
At least it was only a week.
Yeah, that's the thing.
Yeah, you'll never do that again. So
No,
it's a learning-
100%.
learning point.
Steep learning curve, that one.
Mhm.
Too smart for my own good with that sub-query. I was like, oh, look at this. Disaster.
I was going to say I'm a big fan of this site as well.
I
They
remembered that one, but I couldn't remember what it was called, and I was like, oh, I'll just use this one.
so
Yeah, so
there's
this one's a bit
like,
more advanced, right?
but you can do like loads of stuff with it as well.
Yeah, maybe it's worth us adding this to this presentation.
Did you see that? It said, how do you pronounce
Yeah.
SQL? Have no
Yeah.
idea.
Maybe we saw that
Same.
before. And then you said both of them as well.
Yeah.
So I think you need to sign up, but it's free and doesn't.
What's it called?
It's called
If we can-
Mode.com.
We can whack a link
mode.com. Yeah.
on the slides,
That'd be fab.
and
Thank you.
then you can use kind of both of them. I think in terms of like reference material, W3 Schools is like really fantastic, like super easy, accessible basics. Like I'll read it all the time. We did have a play with this one a while ago, didn't we? Which was really good as well.
There's like tons of databases and tables, so
bit
you
more
can-
complex.
yeah,
you
you
can
can-
try out
definitely.
slightly more wacky stuff than you can. The W3 Schools one is like great for basics, but kind of stops.
Okay.
This
This would be
one
good for
has a bit
stage
more.
2 of the
I'd say so,
Yeah.
yeah.
Okay.
But yeah, and if you have any other like questions in the future, just ask.
I will do. Thank you.
No, you're welcome.